We're at the Environmental Management Seminar in Nashville, Tennessee with Dr. Brian Keeper of the University of Georgia. Dr. Keeper just gave a talk about poultry processing changes and their effects on wastewater operations. Dr. Keeper, you reported on results of tests in your lab. Tell us a little about those tests and their importance to the industry.
Well, you know, as environmental pressures increase on our poultry industry, as they seem to be doing all the time, one of our goals at the University of Georgia is really to give our environmental specialists tools that they can take back into the processing plant to make changes to the operation that impact their wastewater. There's tremendous amount of opportunities in the plant, several places where we have byproducts entering the waste stream, and we need to identify where the biggest impact is. And so that when the changes can be made in the plant, this is where we want to put the emphasis on cleaning up our wastewater streams, pollution prevention, not letting it get in the stream in the first place. And so we're trying to put hard science numbers on those tests that will help our environmental professionals make those decisions when they're trying to make changes in the plant.
Can you give us an example of where processing changes have made a difference in the wastewater stream?
Well, we start right at the beginning. We start right after the beginning of the slaughter process. One of the first things we looked at is bleed times. Traditionally, we've done that as part of animal welfare, making sure that animals are killed before they go into the scalder. And we also extend that time, but if we go too long, it hurts us in feather removal. But our research has put numbers to show that the impacts on the organics, the particulates, and the nutrients are significantly change as we change the time of bleeding. We want those times to be as long as possible, so as much blood leaves the carcasses so they can be collected as a valuable product and not enter the waste stream. We showed an impact of one case scenario where we're looking at less on COD, chemical oxygen demand, how much organics is in the wastewater, that relative strength, reduced 3 grams, over 3 grams per bird, which doesn't sound like a lot, but when you're processing 250,000 birds a day, we showed an impact of over $150,000 a year by extending the time that we bleed these birds out.
Well, what is the industry average, and what are the example times, the ranges that might have an impact?
Right now, the average bleed times in the industry are about 90 seconds. It's interesting, though, that when we go into plants and actually put a stopwatch on it, we see quite a range. The lines may be designed to run 90 seconds, but sometimes they're a little bit under that or a little bit over. What we're going to be touting from an environmental standpoint is let's push those times as far as we can. We don't see a detrimental effect on feather removal or other processes in the plant, but that can make a significant difference not only on the wastewater but then the cost of operations, because then chemical costs go down along with the fact that we're recovering more blood for the byproduct rendering market.
Well, I think you used some times in your test involving 60 seconds or 120 seconds. What were the results there?
What we saw was a significant difference, again, not only in the concentration, but when we calculated that to how many grams. A good example was COD. We saw almost 3.4 grams less for birds that were bled the longer time. So it's a little opposite of what you would think logically. The longer we bleed the birds, the more blood we're able to collect, and the less that enters the wastewater stream. So the longer we push that, in the plant scenario that we did, at about 30 cents per pound that this facility was paying to treat their wastewater, to pay the city to treat their wastewater, they saw about $144,000 savings by increasing that bleed time by just a minute.
Well, thank you very much, Dr. Keeper.